Hi, and welcome to Roboconhelp Basics of Robotics Level 2. In this lecture, we will learn about how to decide the size of the wheels. In the previous lecture, we talked about how to build a wheeled robot. So here we will talk about if you are building one, how to decide what will be the size of your wheels. Let's talk about these things in detail. Suppose we take the first example. We'll see here what are different kinds of configurations which you can use for using a wheeled robot system. Over here you can see that a simple wheel is being placed, and there are track belts which are placed on this left and the right side. There are simple motors which are being placed in the center, and the motion is being transmitted to the wheels as well as to the track belt using a single motor on both sides. So one on that, one on the other side. Over here you can see there is a simple motor which is being meshed with this gear arrangement. Over here there is a spur and a worm gear arrangement. So the motor is rotating in this axial direction, but the motion is being transmitted using spur gears simultaneously in the horizontal direction. The same thing is being carried forward using the belt, and the motion is being transmitted to the rear wheels. Uh, Similar performance is being done over here in the third configuration. The motor are being placed again in the vertical direction, how we discussed in the second example, but there are idler wheels which act as another kind of wheels for transmitting the motion between the wheels. If you have limitation of space on your chassis, so here you can find out that the same motors could be placed using nut and bolt arrangement, and the motion can be transmitted to the wheels via belt. If you have to transmit the motion to simultaneously to the two wheels, you can use this kind of arrangement where two belts work on one single motor and the motion is being transmitted. Another good example of an existing model which is being existing in market is uh, transmitting the motion via gear drive system from the rear wheel to the front wheel. Similar example is being followed over here. The motion is being transmitted to the robotic arm using gear arrangement. So here you are able to see that if you are making a wheeled robot, what kind of different configurations you can use, and if you have limitation on number of actuators, you have to use how you can use that. You can have another look at a belt robot system, wheeled robot system, where a protruding arm of wheeled robot is being shown over here. This arm can again rotate and fall back into the same in line of the robot which chassis. And this kind of robot is very useful in uh, robots which are used for bomb disposable squads, or robots which can climb stairs very easily, because you can change inclination very easily with these front cantilever arms. So it becomes easy for the robot to climb any staircase. Another example of extension of this wheeled robot is using idler wheels. You can transmit motion from the rear wheels to the front using again a simple belt. Um, here you can see what kind of different configurations you can find using simple wheeled robot systems. Here now we'll talk about how to decide about the size of the wheels once you are designing your own robot. So here let's look at the dynamics of the wheels before you decide that. So you must know every time a wheel rotates an entire revolution, the robot travels a distance equal to the wheel circumference. So if you look at this example on the right side, if you look, if the robot starts from this position and it just takes one simple revolution, and simultaneously if you place a thread along the circumference, and later on you stretch it linearly on the ground, it will resemble this linear distance will resemble the circumference or perimeter of the whole wheel. Now this velocity is generally found by a simple formula, which is multiplication of the circumference or the perimeter of the wheel into the revolutions per minute, which you have required for certain kind of operation. Suppose you require a velocity of 3 meters per second and you want an RPM of, you have a motor of 100 RPM motors. So using the same formula which is being discussed over above, if you can directly place in the figures and find out the diameter. Suppose for 3 meters per second, the diameter of the wheel can be diameter into pi into 100 divided by 60, which is 100 RPM is converted into 100 revolutions per second, and this way you can find out the diameter. So use similar methodology to find out the diameter of the wheels for your own applications for which you have to make a wheel robot. This brings us to the end of the basic levels robotics 2, and look for level 2 to learn more. Thank you.